again. So you can now take out 2 from each one. You'll have a 38 over 8. They have 2's again. So you can take them out. You'll have a 19 over 4. That's as low as she goes. So there's your slope, and then you just finish off the tension line. Any other homework questions before we begin? Derivatives of logarithms. Justin, you say something?
I think I have, but wait. I'm trying to pull that math.
Alright.
Wait, it was when you find the number 10, it was find the second derivative of y e to the 2x squared. And I found the first derivative, but when you go back to do it the second time,
yep.
I wasn't sure what to do with the 4, I think it was.
You got negative 2x squared inside the e, is that what you had?
Yeah, just like that.
Okay, and you found the first derivative?
Well, it wasn't negative 2x, it was just regular 2x.
Oh, just 2x squared? Okay.
Yeah.
So you found the derivative to be what? 4x e to the 2x squared, is that correct?
Say it again?
You found the first derivative to be 4x e to the 2x squared.
Yeah.
Okay? So now it's a product rule, right? 4x is the first function and e to the 2x squared is the second function. So for a second derivative,
you said 4x to the first one?
4x is, I'm going to consider 4x to be function 1. All right, first, I call it first and second. So first and second in the product rule. So first times the derivative of second, we'll have 4x times the derivative of the second. But the derivative of the second is this entire expression, right? That's what we just computed. So derivative of the second is 4x e to 2x squared. That makes sense so far?
Okay. Oh, yeah.
All right. Plus second e to the 2x squared times derivative of first, which is just 4. There it is. They can be cleaned up a little bit. In general, especially when dealing with e, so now you see that each term has that same expression. So you should factor that off from both of these. So you'd have e to the 2x squared sitting up front, and that would leave you with 16x squared plus 4. If I've been paying really close attention, I would take the 4 out as well, but I'll do it now. Okay? So take the 4 out as well, they both have 4s. So 4 e to the 2x squared, 4x plus 1. Sorry, 4x squared plus 1 would be the way you want to have it.
Oh, okay. He said, well, you had that first one. So that very first one, yeah, no, under, yeah, right there. So it's the first time derivative of the second, but the second is.
This is the second.
Yeah, that's the second.
So I need the derivative of it right here.
But how come that's 4x and not just e to the 2x?
This one?
Yeah.
Because I need the derivative of the second expression. This is the second function. I need the derivative of this right here in
But
parentheses.
isn't the derivative of a log?
E to the 2x squared is this.
Oh, that's right. Okay. Okay, I didn't see that. Okay, that makes sense.
That's good, all right.
And I only use like one type because I don't like to have very many packs.
Make everything all right? Everything all right? Everything all right? Yeah, I'm not so fast. Everything all right?
Yes.
Good.
So,
Any other homework questions? Before we begin logarithms.
that was 3.7.
6. Chain rule. 3.6 number 10, online homework.
We're taking the second derivative.
Second derivative is 3.6 number 10, an online homework. We took the second derivative. First was a chain rule. The second one was the product with a chain. Lee, any homework questions?
above.
Homework. Online homework? I mean,
And I've got 3.5.
3.5?
3.5 is 7.
Number 7?
Right. And I now.
Do it right now. You can. So I can. Where am I? Let me go back to a previous thing.
7.
7.
And question C.
Is it a complicated word problem? Oh no. Okay. Maker.
Two questions. My first question is the building homework is due test day.
Yeah.
And then my second question is you decided to move the project to 27th.
Yes. That's correct. Each of the following two projects, Project 2 and Project 3, have been moved one Monday down. Okay. It was supposed to be that way from the beginning, so it was a mistake on my part. Alright. You say only part C?
Yes, C.
Only part C. What is the approximate maximum velocity of the car? The approximate minimum velocity. So here they give us no function, we just have the graph of the function. I'm trying to enlarge this thing. Okay. So if you want the approximate maximum velocity, what are you looking for in this? This is a function of s versus t, so this is a position graph, right? Position versus time. So what are you looking for to be to be big here? What are you looking for to be large? The slope. Looking for the slope, largest slope, right? And it said velocity, so that means largest positive slope. If it said speed, you'd be looking for largest negative, meaning smallest negative on number 1, right? But the most negative slope, right? Or most positive, because it said speed. So it's velocity, so we're talking about positive. So where does it look like the slope is the largest?
8.
What do you say?
8.
8? 8. 8 looks reasonable. Yeah, I don't see anything that looks any sharper than that, right? In terms of heading upwards. Okay, so now at 8, you need to try to figure out an approximate value for this slope here. How do we find a...
That's my question.
Right. How do you find an approximate value for this slope here? All right. So that's not so easy to approximate these things. Now, how accurate is the homework want you to be? I'm just curious here. Let's say. Where's the actual question? I guess the question is, you have to kill the graph to see the question?
Yeah, or hit medium. No, not that one. Medium? No, not that one.
Just close down here? Let's put this in junk here. Will it move on if I just put it in junk? Should I go on to the next part?
No. You have to get it right.
You have to get it right?
No, you can get it wrong. Oh, yeah.
Can you keep going? What do I do?
Keep going until it says final check.
Final check.
Oh, final check?
I didn't even see it in the version.
Yeah.